So here's CPM Calculus Chapter 2, number 92. So we're given three functions, 3f of x, and we're asked to find all horizontal asymptotes and the limit as x approaches infinity of our function and the limit as x approaches negative infinity of our function. And we're asked to find all vertical asymptotes and holes, if any, and the limit as x approaches our vertical asymptotes from the right and the left of our function, and as x approaches holes in our functions. Okay, so let's start with A. We have f of x equals to 2 of x minus 3 over 3x minus 15. Okay, so this is our unsimplified function, right? So actually it is a little simplified. Let's distribute that 2, and we get 2x minus 6 over 3x minus 15. So here is our unsimplified function, right? Unsimplified. And let's say what it equals when it's simplified. So then let's take out that 2 again in the numerator, and let's factor out the 3 in the denominator. We get x minus 5, right? So this is simplified. This is as simplified as we can go. Simplified. Okay, so now let's look at all of these things. What are the horizontal asymptotes? So we know horizontal asymptotes, we look at the unsimplified version, right? And we look at the highest power of x, which in this case is just 1 in the numerator and 1 in the denominator. And then we look at the coefficients in front of x of our highest power, and we have a horizontal asymptote at y is equal to 2 divided by 3. Okay, so that's exactly how we get it. And then we're asked to find the limits of f of as x approaches infinity of f of x. So this is the horizontal asymptote, right? The limit as x approaches positive infinity of our function. Okay, well, this one again we can plug it in, and we can look at our calculator, or we can look and see, well, when we plug in infinity, we don't care about these numbers, and we're actually going to get, again, any way you do it, we're going to get 2 over 3. Okay? And the limit as x approaches negative infinity of our function, okay? Again, we're going, as x gets bigger and bigger and bigger and bigger, right? We care less about these coefficients. We care less and less about these coefficients, right? I mean, these constants that we're subtracting. As x is huge, these are insignificant. Okay, so we're just going to be looking at 2 times a big number divided by 3 times that same number. These big numbers are going to cancel out, and we're still going to get 2 over 3. Okay, so the limit as x approaches infinity is 2 over 3, and the limit as x approaches negative infinity of our function is still positive 2 over 3. And see how these are all kind of related? Well, they are. You get horizontal asymptote of 2 over 3, and we have our limit as x approaches negative infinity and positive infinity is 2 over 3. Okay, so now let's look at our vertical asymptotes. Vertical asymptotes and holes. So vertical asymptote and holes, we know, so let's put this back in so we can see it, minus 15, x. Okay, so we know for vertical asymptotes and holes, we're going to look at both the unsimplified version and the simplified version. Okay, so for unsimplified, we get denominator equal to 0 at 3x minus 15 equals to 0. We solve for x. We add 15 to both sides. We have 3x equals to 15. We divide it by 3. We get x equals to 5. Right? Our simplified version, we still have 3 times x minus 5 equal to 0. Divide both sides by 3. We get x minus 5 equals to 0. Add 5. X equals to 5. Okay, so they are the same, which means we do not. So these are all the places, right, in unsimplified where our function is going to be undefined. Simplified version goes ahead and removes any places where our function is undefined and just has a hole. But nothing was removed, so we have a vertical asymptote at x equals to 5. So we have vertical asymptote at x equals to 5. Okay, and we don't have any holes, no holes, right? Because our simplified version and our unsimplified version produce the same regions where our function is undefined. Okay, so then we're asked to find the limit, right? So we don't have any holes, but we still want to find the limit as x approaches our vertical asymptote 5 from the right of our function, and the limit as x approaches 5 from the left of our function. Okay, so as it approaches it from the right. Okay, so just looking at here, as we're approaching x from the right, we are going to have, what are we going to have? We're basically going to have something over 0, right? So we know it's going to be over 0. But is that going to be, so let's look at it closer. We're approaching it from the right, right? This number is going to go from like 6 or 10, 9, 8, 7, 6 to 5, right? So it's getting smaller and smaller and smaller. So on our number line, 1, 2, 3, 4, 5, we have 5, 6, 4, 3, 2, 1, 7. So we're looking as x approaches 5 here from the right. Okay, so at x is 6, we know this number on top is 2 times 6 minus 3 is 6, so it's going to be 2 times 3 is 6 over 3 times 6 minus 5 is 3 times 1, so it's going to be 6 over 3 is going to be positive. It's going to be positive, right? It's going to be positive 2. So at x is 6, we go up 2. And as we get closer and closer to 5, actually we're going to keep getting, eventually we're going to be what? When we plug in 5, we're going to get 2 times 5 minus 3 is 2 times 2 is 4 over 3 times 5 minus 0. 5 minus 5 is 3 times 0, which is 0. We're going to go up to positive infinity, basically, is what we're looking at. There's going to be a vertical asymptote here. And from the left, we're going to be approaching positive infinity. And we know that that also means the limit does not exist, because infinity does not really exist. Okay? Even though we know our limit it goes to infinity, we could still say the limit does not exist. Okay, so as x approaches 5 from the left. So as we're approaching 5 from the left, we know that this number is going to be a smaller, so this is basically going to be like 4 minus 3, right? 4 minus 3 is 1. We're going to be positive in the top, and we're going to be negative on the bottom, right? 4 minus 5 is negative 1. As we get closer and closer to 5, we're still going to be positive on the top, and we're going to be negative on the bottom. We're going to now be some positive number over a negative number that's very close to 0. That makes the ratio negative, and so we're going to be approaching negative infinity from the left of 5. Okay, but again, positive, negative, infinity, remember, do not really exist, so we can say D and E as well as saying negative infinity and positive infinity. Okay, so there we go. We don't have any holes, so this is our limit as x approaches 5 from the right and from the left. Okay, so now let's look at part B. So let's look at part B. We have f of x. We have f of x is equal to arc tan of x. Okay, so what are the vertical, oh no, so let's start with horizontal asymptotes. So what are the horizontal asymptotes? So again, we know that the horizontal asymptotes are, well, do we have a greatest power of x? Well, we don't have any powers of x. So we kind of have to keep in mind the graphical form of arctan. We know arctan is just like this up to pi over 2, and like this down to negative pi over 2, right? So this is pi over 2 as a horizontal asymptote. So we know we have horizontal asymptotes at y equals to pi over 2 and y equals to negative pi over 2 because how it's defined, right? Okay, and then let's look at the limit as x approaches infinity of our function, and we know that as we approach infinity, our limit is approaching and going to pi over 2. As x approaches negative infinity, we know we're approaching negative pi over 2. Okay? So again, we can see that how these are related, the horizontal asymptotes. Well, look, here's one of them. These are the same. And here's the other. These are the same. Okay, so yeah, actually we might even be able to predict already that we have horizontal asymptotes where our limit of our function approaches infinity and negative infinity. Okay, so now let's move on to vertical asymptotes. So vertical asymptotes and holes. Well, what are they? Well, looking at our function, does arctan have any vertical asymptotes or holes? Nope, none. So none exists, so we don't need to do any of this because this is just asking to find the limit as x approaches our vertical asymptotes and our holes, so we're done. Okay, so that's part B. Let's move on to part C. Part C now, let's start with the horizontal asymptotes. Again, our function we know is f of x is equal to 4 times x minus 2 times x minus 3 over x minus 2. Okay, so is this simplified or unsimplified? Well, it's nothing yet. The numerator is factored, yes, and the denominator is as simplified as it gets. But we know we can make this unsimplified. So to unsimplify it, we want to distribute these. So distributing these, we get 4, and then you could use the box method to distribute, or any method of your choice, but we have 4 times x squared minus 5x plus 6, okay, over x minus 2, which is equal to, now let's distribute in that 4. We have 4x squared minus 20x plus 24 over x minus 2. So this is now our unsimplified form, right? This is completely unsimplified. We multiplied everything out and distributed everything until we got an unsimplified form. What is the very simplified form? Well, very simplified would be noticing that these cancel out, right? So very simplified is 4 times x minus 3 over 1, or just 4 times x minus 3, right? So that is simplified. That is our completely simplified. Okay, so remember, horizontal asymptotes, we're going to be looking at our unsimplified version, and we're looking at the largest coefficient the largest power of x and the coefficient in front of it. So the largest power of x is going to be 4x squared over just x, right? The largest in the numerator is 4x squared, the largest in the denominator is x. Okay, so again, because the numerator is a bigger power than the denominator, so we don't have any horizontal asymptotes. So no horizontal asymptotes, okay? So that means we are almost done there because we still want to do the limit as x approaches infinity of our function. Well, what is the limit as x approaches infinity? Okay, so if we look at our function as x approaches infinity, we are going to be doing what? Okay, so the numerator gets bigger and bigger and bigger. The denominator gets bigger and bigger and bigger, but this bigger squared is going to overpower this one, and we're actually going to be approaching infinity, right? And the limit as x approaches negative infinity. So what is that? Well, again, as we're approaching negative infinity, we're going to have a really, really big number in the top and a really, really, really big negative number in the bottom. Well, that just makes our function approaching negative infinity. Okay? So these, again, anytime you have the limit approach as f of x approaches infinity, the limit of our function x, of our function f, well, I'm getting sleepy, as x approaches to infinity, equaling to infinity, we know that that does not exist. Okay, because we're happy to say it's equal to infinity, but we know infinity does not exist. So voila, again, it's related to no horizontal asymptotes. And these two questions, the limit as x approaches infinity and negative infinity, are answering the question of horizontal asymptotes. So that's what we need to notice, the pattern here in this problem. Okay. So now we're asked to find the vertical asymptotes. So vertical asymptotes, remember, are where, and holes. So we're looking at where the denominator is equal to 0 because that's where our function is undefined. So we have x minus 2 equals to 0 or x equal to 2 is where it's undefined, right? But when we simplify it, right, when we get to, so this is from our unsimplified, when we simplify it, we have no undefined points, right? So this means this is not a vertical asymptote, this is a hole. Okay, because there's no undefined points after we simplify it, this undefined point is just a hole, it's not an asymptote. Okay, so let's plug in at x equals to 2, let's plug it into our simplified function, and we get 4 times 2 minus 3, or negative 4. So our point, our hole, is going to be at 2 comma negative 4. X is 2, y is negative 4, so that's our hole. Okay, so we have a hole at x equals negative 2, comma negative, x equals 2 comma negative 4. So let's look at our limit as x approaches our hole. So limit as x approaches 2 of our function. Well, we know that is just going to be, we plug it in to our function in simplified form and we get negative 4. Okay, so we have seen our horizontal asymptotes in part C, our vertical asymptotes, which this function has none, right? So no vertical asymptotes. And our holes, we have a hole here, and our limit as x approaches to 2 is equal to negative 4. Okay, so this ends Calculus Chapter 2, number 92.